Welcome everyone to an introduction to all data enterprise integration with FME. So today I am joined by a lovely panelist of our three SAFers here. So I'll hand things over to Sienna to introduce herself.
Hi, my name is Sienna. I'm a customer solutions specialist here at SAFE Software. Basically, my role at SAFE is to allow users to get the most value out of their FME deployment. And I'm joined by Dan, so I'll let him introduce himself.
Nice to meet you all. My name's Dan. I'm also on the customer solutions team. So as well, pretty similar to Sienna, helping our users get the most out of FME. Don, off to you.
Yeah, I'm Don Murray. I've been around since the beginning. Some said since the dawn of SAFE Software. So there you go. And I'm really happy to be here. Sienna and Dan are superstars, and they're going to wow us all and show us what FME is all about. So.
Awesome. Thanks all. And I will note as well, we do have the team on standby under the questions tab there. So if you do have any questions throughout the webinar whatsoever, please do get those into the questions tab, and we'll have a live Q&A period at the end as well. And then if you do have any audio issues throughout the webinar, just click that help button on the bottom left for 4 simple steps to take. And then also to note, we do have the chat tab. Keep letting us know where you are tuning in from there. And lastly, you can share your emoji reactions with us throughout the webinar. All right, with that, I will go ahead and get our presenters to turn off their webcams to save on some bandwidth for the rest of the webinar here. And I will hand things over to Dawn to take us through our intro.
Great, thank you. And I just want to say to everybody attending, just remember this is the beginning of the conversation. So if at any time during the webinar or after the webinar you want to reach out to us, we love talking to anybody about all their data challenges. Okay, let's get started here. So one of the things that we see at SAFE Software is we see too many organizations are spending too much on integration tools and getting too little. And this can be in terms of how much they're spending to purchase a tool, but certainly how much time they're spending on getting the integration tool to do what they want. And our aim is to fix that. So why data integration? What is the value of the FME platform? Data is the most critical business asset we see for any organization. Using data better to make better decisions is what data integration is all about. And when we look at the landscape of enterprise integration, this is what we see. We see data sources on the left here, hundreds and hundreds of data sources. They live in applications, they live in databases, they live in GIS or spatial systems. And on the right, we have the people who want to use the data, business users, customers, the community, decision makers. And the customers today can be AI. So they're the ones who actually want to get all that access to that data, that information to make better decisions, to do their jobs better. And in the middle is data integration. In this case, we're talking about FME. Could be data integration, pulling together multiple data sets, application integration. Real-time data is becoming more and more. So whether that be event-based data or high velocity data streams coming through from things from Kafka and systems like that. Data quality is key to everything. We're hearing more and more about data quality. And of course, last but not least, automation. You want to have the tools do this so you can share data and automate your entire enterprise. Just looking at data quality, Gartner just recently published a study where they surveyed organizations, and they found that on average, each organization is losing about $15 million per year on data quality. That's for each organization. And I have never been to a customer using FME who is not using it for data quality. Data quality, data assurance, data governance, all that is key to really building a mature data processing enterprise integration platform. So who are we? We are SAFE Software, and we are the only all data integration platform. When we look at spatial data, this is one of our differentiators. In fact, our support for spatial data is so big compared to the competitors, we can call it an unfair advantage. The thing I don't like about this slide actually is the blue dot is actually way too big, but we had to fit the word competitor in there. So it actually overplays the amount of spatial data support that our competitors have. In fact, they just don't do it. In fact, many of them come to us and ask us, hey, can we integrate with you so that we can do something with spatial data? Because right now they're ignoring it. When we look at our platform, really simple. We have Form where you build and you connect all these things. A no-code environment, a really nice environment to connect all your thousands of systems. And then you want to automate it across the enterprise. So whether that be events, whether that be high-velocity data streams, whether that be no-code web apps, whatever you want to do, that's where FME Flow at the enterprise level is. And if you don't want to run your own FME Flow, we have a cloud offering, FME Flow hosted. Why spatial? The world we live in is spatial. How many ways would you use spatial data without even thinking about it? Spatial data is used from everything from when we wake up, finding our cup of coffee. Even if it's in your own house, you still have to navigate to get it. When you're on the road, where are you going to eat? Where are you going to get a coffee? When there's an emergency, could be a fire, could be a flood. Spatial data is key to saving lives. Pacific Disaster Center in Hawaii, they use FME like crazy to help them manage those fires as well as track hurricanes. Spatial data also creates experiences that only exist in the digital world. Think about virtual reality. That is spatial. Whenever you're in a virtual reality environment, that data is all spatial. When you travel somewhere, spatial enhances your experience. You plan where to go, what sites to see. All those things are spatial. It's all about spatial data. Yet many organizations don't use spatial data when making decisions. In fact, when we start talking with clients, a lot of them recognize that spatial data is the missing piece in their entire enterprise integration strategy. Spatial data is everywhere. People are starting to realize that. It's in all types of data. It doesn't matter what your traditional database is. You probably have a customer address. Your businesses are located somewhere. Maybe you have fleets in the field. They're always somewhere. The more you start to look, you realize spatial data is everywhere. And when we talk about all data, we don't just mean all data types. We also mean all data velocities. So it could be transactional, could be event-based, could be high-velocity data streaming coming through something like Kafka, could be ETL, could be just data loading. Spatial data, of course, is everywhere. Everyone is someplace all the time. Everything is someplace all the time. Everything happens somewhere all the time. Location, location, location. And it's time that all enterprises start using it, because you cannot afford to make decisions without using spatial data. In fact, Gartner has started looking at this, and they have this term called the digital transformation. And digital transformation requires that you embrace spatial. Without spatial, you just don't see some relationships between things that are inherently spatial. So you're going to miss market opportunities. You're not going to allocate resources. You're going to fall behind your competitors. Let's just look at a few digital transformation versus digital optimization. In retail, digital transformation will actually enable you to analyze foot traffic, optimize your store layouts, better in-store personal experiences. You can't do that with digital optimization. They just can't see what's actually going on. In healthcare, digital transformation again, real tracking of equipment. Where is that IV pump? Or now we're working with folks who are putting trackers on IV pumps and other critical equipment. Hospitals can be chaotic. Where are those patients? Every time you go to the hospital now, they'll put a tracker on you so they know where you are. Hospitals are confusing. People get lost. And then, of course, just to track the understanding of outbreaks, go on our website, look at Blue Dot, and you'll see one great example of how they're always using FME and spatial data to track where the next outbreak is going to happen. Transformation, we can't even imagine a mapping application now that doesn't engage real-time traffic analysis. There's an accident, so it's going to reroute you. I mean, I remember the day when before we would go away, we would print the turn-by-turn directions out on a piece of paper, and the person next to us would tell us where to turn, completely oblivious to what was actually going on in the world around us. The time estimates were easy to beat, or you would be way behind. We can't even imagine going back there. That digital transformation is so transformative that we just can't imagine going back. And that's a great illustration of what the difference between optimization and transformation actually is. Once you taste transformation, you can't go back. Food production, again, We had a great talk with EI, was at the Gartner show, and they were taking images, satellite images of crops, and they could detect corn rust before farmers knew it was there. And so what they would do is their client would move the corn rust treatment to warehouses closest to the farmers that had corn rust. So when the farmers went there was always corn rust treatment. They wouldn't run out. And that was beneficial for the farmers, beneficial for the folks who sell corn rust treatment, but also the yields went up, keeps food prices down. So it's just a win-win. And in finance, of course, fraud, using digital transformation, we're able to really tune in tightly on, is it actually possible that somebody did something at point A and then 10 minutes later at point B? And just to really, location is such a key part of detecting fraud. Where is that transaction actually coming from? And fraud is just a big problem, and spatial is key to addressing that. Spatial data, of course, is being embraced by more and more companies. This is just a small set. When any organization does look at learning spatial, they come to us. Why? Because the first thing you need to do is be able to get spatial into your system. Spatial data is scattered like any data all over the place. And we are the only digital transformation enterprise integration platform that can do it. Okay, here again is a view of FME, thousands on the right, thousands on the left of different systems that we connect. And then FME was that thing in the middle that just a graphic to show you just some of the things that FME does and some of the use cases. Again, we're the only one that does spatial. So basically, when you think of FME, the first thing is you got to connect to all the different systems. And that's done on form. You can see through the icon there. Integrate and convert thousands of information across thousands of systems. Transform it in the no-code environment. And then when you want to automate your environment, whether it be event-based streams or data streams, that's where FME Flow comes in. And you're going to see all of that in the rest of this webinar. Okay, I'm now going to pass it off to Dan.
Awesome. Thanks, Don. Yeah, so in this section, we'll be taking a look at connecting to data. So this means connecting to your source data sets and your output data sets, or what we like to call systems. So in this part, I'll be focusing on FME Form, which is the no-code authoring environment for the FME platform. With FME, we're able to work with all data, including up to thousands of input and output systems, as well as transform, enrich, and validate it all through the no-code interface. FME is a flexible tool allowing for granular control over your transformations. Workbench is the FME application used to author your translation scripts. So our workspace is the file created by FME Workbench. And our source data can come from a variety of systems, such as files, databases, or data from web APIs. So to connect to your source data sets, we use a reader. In a Workbench workspace, the readers are listed in the Navigator panel, which you see in the middle there. And there you can find all the settings and parameters for that particular type of reader. Each reader reads a specific system, for example, an Excel file, or an ArcGIS Online feature layer, or a Snowflake table. The layers or sheets or tables of data in your datasets are called feature types in FME, which you see on the right there. And they appear as brown boxes on the main window in Workbench, which we call the canvas. Here we can see what the canvas looks like in FME Workbench. There are 2 reader feature types here and 1 writer feature type. These may be layers in a GIS dataset, tables in a database, or sheets in a spreadsheet. In FME, the data flows from left to right. So as you can see there, it starts off in the readers and then flows through the rest of the workspace. If you notice the little green spyglass or eye boxes at each output port, these appear after running the translation. And by clicking on these green boxes, you can view the data at that point in the translation, which is a valuable tool while building out your workspaces. It's important to be able to inspect your data before, during, and after the translation to ensure that the source data is what you expect, that the transformations have done what you want, and that the data has been written correctly. So when you run a translation in FME Workbench, a feature cache will be created at every output port, which you again see in green there. And if we click on that cache, it'll be displayed in the visual preview window. And this visual preview window supports tabular data, 2D data, 3D data, such as point clouds. The last step here is writing out your data. So writing is pretty similar to reading data. There are writer feature types that belong to writers, and each writer writes to a single format. So again, you might be writing to an Excel file or a database table. And these feature types that you see on the left here are the layers or tables or sheets within a writer's output data set. The parameters for a writer can be found in the navigator window, again, seen in the middle there, with parameters being unique to each and every format, and allows for deeper and granular control over what's happening when your writers run. So in our first demo, we'll take a quick look at creating a simple workflow using readers, writers, and transformers. And after that, we'll talk more about what transformers are and how they let FME change your data to fit your needs. So I'll share my screen here, and we'll be opening up FME Workbench. So this is a blank canvas in FME Workbench. This is where we author out our workflows. And the first step here, as we mentioned, is adding a reader to our canvas. So we've got our three, what I like to call key tools at the top here. We have our reader, our writer, and our transformers. So we'll add in a reader here by clicking on the Add Reader button. I already have this configured to read in an Excel file by specifying the format here. And I've gone in and selected our Excel file. I'll click OK to add our reader to the workspace. And as you can see here, we have our reader feature type. So this represents a single sheet within our Excel file. With feature caching enabled, I can click on Run just to this. And that'll run to this point in our workflow. And by clicking on the Inspect Feature Cache button here, we get a tabular view of our data. So we get some more information on what our data looks like. And this is just the first step to building out your workflows, to making sure that your data looks valid and it's being read incorrectly. One thing I noticed here is that we have 110 features and we were only expecting 100 features. So this tells me that we might have some duplicates in there. To remove those duplicates, I can use a transformer. So we'll click on the transformer button there, and we'll add in a duplicate filter. We'll double click on that to add that to the canvas. An FME form is a drag and drop interface, so I can just drag and drop between our reader and our transformer. The red exclamation mark here tells me that I need to configure the parameters on this transformer in order for it to work. So I'll double click to open up the parameters. And I need to set a key attribute. So this is where we're going to be detecting those duplicate features. I'm going to select ID since that's a unique attribute. And I'll click OK, and I'll click OK again. And I'll run again to this point in our workflow. So you can see at this point, we've now detected 100 unique features and 10 duplicate features. So in FME, you can work with multiple different streams through your workspaces. So now I can just use these unique features and leave those duplicate features behind. The last step here is to write out our data. So I'm going to click on the writer button here to add a writer. And this has already been set to a Microsoft SQL Server non-spatial format. I've specified a database connection here. So these are reusable connections across your different workspaces that you can use and share with others in your organization. And I'll just accept the default parameters and click OK. We're then prompted to provide some information for our feature type. So again, this feature type represents a table in our database that we're going to be writing to. So I need to provide a table name. This could be an existing table or a new table that we're writing to. And we'll click OK to add that to our canvas. I'll then connect our unique port to our writer. And you can see it populates those columns, those fields. So we now know those are going to get written out to that new or existing table. And then we'll click run on our writer to run the writer. We can see that our translation was successful down here in our translation log. And one last step here is I can click on the View Written Data button to make sure that our data was written out correctly. So I can see our data was written out here and all our fields exist. So everything looks good here. And that's just a quick example of what a workflow looks like in FME form with our readers, our transformers, and our writers. So we'll go back to our slides here. And we'll look a bit more into our transformers. So we saw a little bit of transformers in the demo, and now we'll talk a little bit more about what they do and how they can change your data to fit your needs. So FME enables you to transform your data for any purpose, and our broad library of transformers enables you to integrate your data to suit the best fit for purpose applications, formats, and standards that you've chosen. This increases the value of your data by making it usable where, when, and how it's needed. And the data validation capabilities provide high quality assurance and high quality data. You can also easily expand your workflows to include new data sources or new transformations as they become available. It's really that easy with FME, and one of the strengths of the platform is being able to go in, manage, edit, and share your workspaces with others. So here's just some examples of the different transformers that we have in FME. And again, these are just a few of the transformers that we have. We have over 500 different transformers that you can use, and that number is always growing. So on the left here, we have our attribute manipulation transformers. These allow you to create new attributes, create new fields, rename those, or perform mathematical expressions on your data to calculate new values. You can also perform attribute validation, whether that's to do with data quality, data assurance, and this really provides you with governance over your data, ensuring that your standards are met. FME is also a strong tool for performing spatial analysis. So we can ask questions such as, do the data sets overlap? What's the distance between them? And are these objects close to each other? And what's the density within certain areas? So these, again, are just a few of the different transformations that you can perform. But FME really has so many different possibilities as to what you can do. And that's one of the key things with FME is that you really get that granular control over the different steps in your workflow, so you can build those out to how you want them to be. In FME Workbench, as you saw, we guide features through the workspace using connection lines. And with many different transformers and many different readers and writers, you're going to have multiple connection lines coming from different parts of your workflow. And if you do have multiple connection lines coming out from different ports on transformers, then a copy of all the features will go along each of these connection lines. If you want to merge the attributes of one set of features into another set of features, then there are transformers that can do that, such as the feature joiner. With the ability to have multiple streams, you aren't just limited to one workflow per workspace, and you can utilize multiple streams to enrich our data, validate it, and do so much more. So next we'll be taking a look at an FME Flow app, which provides an organization with data governance over the data submitted by their staff. So this is what we like to call a data validation app. So let's take a look at the full workspace, and then we'll take a look at the app in action. So I'm going to share my screen again here. And as you can see, we have a complete workflow built out here. So at the beginning of our workflow, we are reading in our AutoCAD DWG file. This is a data set of water distribution lines. And before we load our data into our ArcGIS Online feature layer, we want to perform some data validation. So we're first going to be calculating some statistics on the count of the features. We're going to be checking that the geometry is line geometry, since we're only working with water distribution lines. And then we're going to be performing some attribute validation, such as confirming that the diameter of these pipes are greater than 0, and that the objects pass OGC tests and various other tests. If I just zoom out to see the broader workspace here, we then have some more operations here at the end where we're writing out our data after creating some HTML reports. Once we'd finished building all this workflow, we published this up to FME Flow and created a FME Flow app through the FME Flow interface. So right now we're just going to be focusing on really the value that you get out of building these workflows, and how FME Flow allows you to automate these and allow your users to come in and run these workspaces themselves. So let's go into our Flow app. And this is just a sample Flow app that we've created. I'm going to download the bad data set so you can see what happens when our data doesn't pass validation. We've dragged and dropped it into our source dataset parameter here, and now we can click run. What's happening now is that FME is running that workbench in the background, and as a result, it's going to send us back an HTML report on our data validation results. So as you can see here with our bad data set, we've received an invalid submission, and we've received the time of our submission, as well as more information on the issues detected. We also have a graphical view of our data, so we can see exactly where on our map which features have failed validation. And we can even zoom in and click on these features to get more information, such as the feature ID and why the feature failed validation. Again, you get further information at the bottom here, such as the tile, the feature ID, the diameter, and the error remarks. So you can see here with our second feature that has a diameter of 0, that's going to fail our validation since the diameter of the pipes need to be greater than 0. And that's then provided here with the invalid attributes remark. If we go back to our app and we download the good data set, and we'll just drag and drop that into our parameter there and click run. That's going to run our workspace again, and it's going to pass the validation tests. And as you can see, we have a load complete message with our data validation successful and the date that it was loaded. So we also get information here, such as our number of features added. And again, this has been written out to that ArcGIS Online feature layer as a result of passing the validation. So this, again, really allows organizations governance over their data that's entering their data sets, their databases, without having to go in and manually inspect those features. So let's go back to our workspace and see how we build that out. So the first step here is reading in that line data. To do so, we can add a AutoCAD reader. So I'll just paste that in. In here in our reader, you can see we've also specified our coordinate system. The next step here is then counting the number of input features. So we're doing this with the statistics calculator. I'll open up our parameters here. And you can see we've just selected one of our attributes that we want to calculate those statistics on. And then we're just getting the total count. We're then filtering our geometry to just line geometry features. So if I open up our geometry filter, you can also set up additional output ports if you want to check for multiple different geometries here. The next step is then validating our attributes. Again, we're validating that our diameter is greater than 0. So we'll open up our parameters here, and you can see we're making sure that our diameter has a minimum length of 1 and that the value is greater than 0. The last step here in our validation is to use the geometry validator. And this allows us to validate against OGC tests as well as various other tests. So we have our OGC simple and OGC compliant tests, but if we wanted to, we could also select one of the various other tests here. And once we've finished performing our validation, we can then add in our other part of our workflow, which allows for the HTML reports. So we'll go back to our slides and stop sharing our screen. So just to recap, during our demo, we had an example of our validation passing and our validation failing. So this again allows users to come in, submit their own data sets and run that through the workspace without ever having to configure that workspace themselves. They're also provided with information back. So if they do need to go and fix their data sets, they're not left in the blue. They can go and find those features that have invalid values, such as the diameter and those that have failed the different OGC tests. With our successful report, we are given a submission ID and a timestamp, and with our invalid one, we're provided that list of invalid features. So numerous of our customers have implemented this data governance workflow using the FME Flow apps. For example, the city of Henderson has reduced their data integration time by 75%. And the key here is that they're removing that manual error and duplicate work, allowing their employees to do other more important work within their organization. Submissions are processed instantly. So instead of relying on someone to manually review the data, those submissions are sent through immediately if the data passes validation. So now I'm going to pass it off to Sienna, who's going to talk a bit more about how you can automate your workflows with FME Flow.
Thanks, Dan. At FME, we often say FME Flow is how you automate your workflows. And yes, it is true. You can automate your workflows in response to things like files arriving in a directory or webhooks. However, FME Flow allows you to do so much more than that. FME Flow acts as a notification center. If you have critical processes running on FME Flow, FME can keep you informed real time. So whether it's a database hiccup or a major event, FME Flow can notify users via email. Managing workflows on FME Flow is incredibly easy. Oftentimes we have a few FME Form users. They're all uploading their workspaces to FME Flow and running them. So you need to be able to manage these workflows efficiently so that they can all work together. You can do that very easily on FME Flow. Lastly, FME Flow enables seamless workspace sharing. So whether you're a seasoned FME Flow or just benefiting from a coworker's work, FME Flow allows users to process data without needing to build workspaces from scratch. To understand FME Flow, first we need to understand its relationship to form. So let's take a user and we'll call him Dan. Dan creates a workflow on FME Form. Think about the digital plan submission demo just shown. Dan wants to automate this process and share the data he created with multiple users. To be able to do that, first he'll publish his workflow from FME Form to FME Flow. So publishing is really just our way of saying we're going to take a file from FME Form and push that to FME Flow. FME Flow is a web-based software, so that file can be shared amongst different users. In FME Flow, you can automate your workflow using the FME Flow automations. So this allows you to run your workflow based on different trigger events, and we'll go over trigger events in a little bit. On FME Flow, you can also use FME Flow apps. So these are code-free applications that you can build entirely on FME Flow. You can customize these applications so that
No one has to know that it's really running on FME Flow. You can add your own logos and your own imagery to these applications as well. Finally, if Dan was using something like an IoT stream, he could also automate this on FME Flow, so it's continuously processing his data. So let's take a look at an FME Flow automation. FME Flow automations are incredibly easy to use, and that's because they have a drag and drop interface. So Dan can build his automation, which can be really complex and help him resolve any repetitive tasks by simply dragging items onto the screen. All automations start in the same way. So first you have a trigger. This trigger event could be something like running a workspace on a schedule or running a workspace in response to various things. The next step in an automation is to transform your data. So this is using a workspace action. So you can imagine automatically converting any attachments from an email into a destination data source. Finally, you can notify yourself. So again, using the example of a database blip or a network issue, if something does occur, you can set up an email to notify yourself if there's any failure in the workspace or the trigger. Here is an example of some of our triggers available on FME Flow. We have push notification triggers. So this is when a third party will send a message to FME Flow. A good example here is the email SMTP trigger. What this does, it will wait for an email to arrive. Once the email arrives to the internal SMTP server in FME Flow, we can process that attachment and get the data where it needs to be. We also have pull triggers. So when we can't implement a push trigger, we have a pull trigger which will look at a resource or a data set and see if new data has arrived. Some example of these are an FTP watcher, a Dropbox watcher, or just a file or network resource drive watcher. This is an example of what an automation looks like. So here we have workspaces that can be run in parallel. So they're workspaces running at the same time, or you can also choose to run your workspaces in sequence. It's important to note that we can use enterprise integration patterns and very complex ways of running your workspaces if needed, and this is completely done without any code. Next, we have FME Flow apps. So Flow apps are, again, an easy to use web-based format, so you can share your workspaces if needed. You can choose whether these Flow apps are authenticated or not, and users can add their own logos and branding if they need to. Again, completely no code required. Now, let's talk about some real-life success stories. So first, let's talk about the city of Oshkosh. This is a real-life example where the city of Oshkosh needed to integrate their data into their child abduction response team leads tracker application. So they're taking data from a webhook and automatically pushing that to ArcGIS Online. Before, this was a manual process, so an individual would have to go in and manually update this leads tracker. Now, because it's done automatically, the city staff can focus on more important things like actually following up with users reporting any incidents, rather than spending their time manually mapping out this data. It's been so great for the city of Oshkosh. They even said that these updates used to be time consuming, and now this automation is their missing component. Another example is the city of Naperville. So they needed to automate their service requests and their work orders from a few different departments around the city. Before, they're spending a lot of time manually mapping out these work orders, and basically they have 3 full-time staff focusing their effort on this. Now they have FME do it, so it's automatically integrated. They don't need these 3 staff to focus on these menial tasks. Instead, they're focusing on more high-value work. And this has really increased collaboration and formed stronger relationships between their departments. Now let's talk about streams. What makes the FME special in working with real-time streaming data is our ability to process that data before it's sent to a destination system. So we can analyze and process the data before it's sent to its final application. This allows us to filter and correct data before it's sent to a third-party system. We can also use real-time event notification. So let's say in a fleet tracking example, you're tracking a bunch of cars. You can set up a boundary, and if a car crosses that boundary, you can be notified right away. This is incredibly useful for managers or people concerned about where their fleets are. Some other use cases of streams, so we've seen it in cases where users want to manage their customer orders or their airline reservations, as well as GPS sensors or smart meters from a city. Basically anything that has a really high volume of data that you need to process right away. Here's an example of some of our supported messaging protocols. As you can see, we support a lot of protocols and we're very agnostic to who we support. So if you're noticing we're not supporting a protocol that you're using, please contact us and we'd love to hear about it. And we can see if we can implement that in the future. So what makes FME stand out? You can have unlimited managed users. So it doesn't matter how many employees you have in your organization, everyone can have access to FME Flow and be able to process their data efficiently. The second thing is we have flexible engine deployment. Think about engines as the processing power behind your FME Flow. Basically, you can deploy your FME Flow however you want, and we have very flexible infrastructures. The third is we have advanced engine management. So think about how you're running your jobs and getting the most value out of your engines. We have some really complex rules that allow you to manage your jobs efficiently so you are getting the most value out of that engine purchase. So in conclusion, we are the only all data enterprise integration platform. It doesn't matter what your data is, we can work with it. We have lots of solutions, and notice that they're all no code. So you do not have to be a programmer to be able to use our interface. This also means as people move on from your organization, these workflows can be passed down, and then they're all self-documented themselves because they're using these components that are within FME. As well, we have an incredibly vibrant user community. We have over 29,000 members on our community. We've been in the data solving data challenges space for over 30 years. We have 200,000 users worldwide. And I'll pass it off to Elizabeth.
Awesome. Thanks, Sienna. I will go ahead and share my screen here and walk us through our resources to help you get started. So here at SAFE, we are all about free resources. A few listed on the screen, as you'll see. Get our ebook, Spatial Data for the Enterprise. We also have our FME Academy and Knowledge Base, which are great places to have guided learning at your fingertips. And we also have a lot of how-tos and demos available there. And lastly, our webinars. So tons of upcoming and on-demand webinars. Feel free to use the search bar to search for whatever topic might be most relevant or beneficial to you, safe.com/webinars. And lastly, I'll note we have podcasts as well that we've recently started in the last couple of years. So if you're looking for more audio learning, please do check those out. In terms of next steps to take, our FME Accelerator course is a great place to get started learning the basics of FME. It's 90 minutes free of charge. I personally took this course and found a lot of value from it in learning the basics. And for those that are currently members of our FME community, we do have a community badge code you can redeem as a thank you for joining us. It's on the screen there, and I'll also leave it in the chat here shortly. If you aren't yet a member of our FME community, we definitely encourage you to check it out. It's a great place to both network with other users alike and get advice from experts. And I'd like to re-emphasize once again, similar to what Dawn said at the beginning here, we'd love to help you get started and chat with you about anything data whatsoever. Contact us at info@safe.com. All right, with that, I will invite our presenters on stage here, and we can take a look at the questions panel together. Awesome. Lots of great questions that came in. So thank you everyone who was able to drop one in there.
Yeah, no, it was good. Sorry for the audio problems. I don't know what happened on that, but yeah, strange. And I did click refresh as our friend Lee Powell said, and that worked. Great.
Awesome. Yeah, it looks like that's doing the trick for everyone. Thanks everyone for your patience. Glad that helped resolve.
Okay, so yeah, Reed asked a good question about Databricks, Delta Lake, and the Mosaic framework and things like that. And that definitely is an entire area that we're working on. So Apache Iceberg comes up as well. In the latest, I'm not sure if it was the latest release, but certainly in the latest beta, we've added support for DuckDB. And DuckDB can sit on top of many of these things. It can sit on top of Delta Lake. It can sit on top of Apache Iceberg. It's a good, for that. Our work is not done there. So if anybody, we'd love to talk with you to see, what exactly you would like to do with those. And on the same vein, somebody asked about Microsoft Fabric, and one of the big things about Fabric, of course, is OneLake, and OneLake does use Delta Lake, and so again, we'd love to have a conversation on that to make sure that we understand exactly what you want to do. So when we build it, we build the right thing, not just an interesting thing. So yeah, we do, and again, we do Parquet and GeoParquet. So Lee, love to follow up with you on that. So yeah, Dan, do you have a question you want to look at?
Yeah, just scrolling through some of them here.
Howard had one in the chat panel. Not in the actual questions panel, though.
Oh, yeah. So, yeah, beginning of the demo, we dumped those 10 duplicates. So you want to analyze those elements in FME, just in case one of them is the one that you want to keep. I guess you can use testers. We have test filters. You can look at your data to see, those values contained within, and do further comparisons. So if you did want to keep those features, you could kind of do further analysis on them through our other transformers there. But there's no set way to do with FME. That's kind of the nice way with the FME platform is that you really have control over it. So, it's up to you how you want to work with your data and how you want to kind of do that further analysis there.
Awesome. Any other questions we might want to touch on or elaborate on?
I like John's question right at the beginning of the webinar because I feel like it can be almost philosophical, and that's what are the key differences between good and bad quality data. We talk a lot about how you don't want bad data and you want good data, but what does that actually look like in practice? So maybe we could do a bit of a roundtable on that. Sorry, Don, you're muted.
Yeah, so good data, there's the obvious answers. It's data that is accurate and all the values apply to the schema. When it comes to, there's been some interesting discussions when it comes to Gen AI though, and your good data. And that's, when you're using Gen AI, you need to also be aware, is your data, biased? Are the questions you're asking biased? So let's say you're, a really expensive high-end department store, then you can't ask general questions about population because of course your customers are only the ones who can afford to shop in your in your store. So it's been interesting as we go to these different conferences and the topic of AI comes up and just how the whole importance of data quality is is more important than ever, because Gen AI can just, consume so much data so quickly and make decisions. And obviously bad data is going to cause it to make bad decisions. But it also, now the questions you ask might be more than you would have asked before, because now effectively your query language is natural language. So, and when it comes to spatial, of course, want to make, good data is data that accurately represents where things are, so it can be the accuracy of the data. And Sienna had a good, I think it was Sienna, were you the one who did the demo on validating the data, or was it in Flow, or was that Dan that did that?
That was Dan.
Yeah, so that was a good example as well, making sure that data being submitted but from the field actually meets the schema. And we're seeing, in airports and local governments, and where data is being collected by an outside organization, making sure the data being submitted actually fits in with the schema and the expected format, and then for data governance at the point of being submitted. And you can do that with FME Flow apps, because you can't automate anything if your data doesn't fit with your CAD standard or your GIS standard or other standards. And so so anybody else want to chime in?
It just reminded me of the book, How to Lie with Maps, where it's kind of like there's lots of ways you could potentially skew data. So even if like the raw data is good, there's lots of ways you could potentially skew it to kind of fit a certain narrative. So I think it's so much more than having data standards. Like there is a process to it, and like not even one that I am fully aware of, but I think Dawn's point with AI is really good. Like if your data is inherently biased, the answers you get from AI will be inherently biased too. So it's really interesting topics. We have a new question.
Yeah, I can take a crack at this one. I'd say for sure, there's lots you can do in FME, but there are, even for myself with some of the work I do, sometimes you just need to use a Python script. So whether that's calling, an ArcPy library, or, as long as you have those library files sitting on your machine, then you'll be able to use those with FME. There shouldn't be any barriers there. So it's kind of the nice thing there. And the same idea goes for formats as well. So, or systems that you want to connect to. We do have, if you have a JDBC driver or ODBC driver, then we can connect to your database that way. Also through REST APIs is a very common way to connect with different systems, especially when it's a web system or a business system that you want to connect with.
Mm-hmm, mm-hmm. Yeah, and there's also R. So one of the things we've done is we've worked really hard to make our whole environment no code, but we recognize that the world of Python is massive and the world of R is also massive. So we built something called the Python caller, so you can invoke any things that you want to use in Python, and the R caller for anything you want to do in R. And so.
I have one final point on this is if you have not used the AI enhancing tool in the Python caller, it is great. I am much more likely to use Python now that I have that tool.
Yeah.
And just putting in the chat as well, we have a great Python and FME basics tutorial. So I've put a couple of resources in the chat kind of as the rest of the panel has been answering questions here. So the first one's for database tips and tricks for detecting schema drift. That was more related to Lee's question. And then the Python question, I've just linked to the Python basics tutorial for you. So we have a lot of great resources on the FME community, which Elizabeth has already mentioned there, but it is something that is very easy to do a quick Google search on FME and getting started with insert your topic here. And typically we'll have something that'll help you get up to speed really quickly on that specific topic and let you set you free.
Mm-hmm. Yeah, and just a different topic based on Lee's comment there. We're seeing a lot more activity with FME with high speed velocity real-time things. So whether that be Kafka, whether that be Confluent, which is Kafka hosted, or Red Panda. So we're testing with Red Panda now, which is a competitor to Kafka, but it's 100% Kafka compliant. And so, but we're verifying that we, just to make sure. So yeah, so anybody want to talk about real time, just reach out to the team and we can get you in touch. Yeah.
Looks like we've gotten to most now. A couple new ones have come in.
I think those ones were in response to Wilfredo's question about importing Trimble GPS data, the .ssf format. Looks like Howard's giving some hints to Wilfredo there. Unless anyone else on the panel has experience with this, I honestly wasn't sure. I had never heard of that format file before.
I'll follow up with Trimble. We have a great working relationship with them, and if you go on our web, our hub.safe.com, you're going to see a lot of the things that are published that are actually published by Trimble themselves. So we'll reach out and find out about the SSF format. And yeah, so great question.
Awesome. Yeah, just final call out to the team. Is there any other questions we might want to get to before we wrap up here? Oh, I think we're all good. Okay, so just to note, if you do have any other questions that come up in the next couple minutes here, we will stay online on the back end in case any more do come in. But if they come in after, if there's anything we can help you out with getting started or any questions about data, once again, reach out to us, info@safe.com. And with that, huge shout out to our team for all their time spent creating the content for today. We hope you gained a lot of value from it. And thank you so much for your time in attending as well. We hope you all have a great rest of your day. And if you do have a moment to fill out our webinar survey, we really appreciate any feedback. Thanks so much, everyone.
Thank you. Bye.
Thanks, everyone.